Okay, students, I am Sam Harrison, Professor, Department of Rovi College of Engineering and Technology. Today I am going to discuss about the electromagnetic force. The electromagnetic force is given by Lorentz force equation in the year 1853 to 1928. The force is equal to Q into E plus U cross B. The Lorentz force equation is quite useful in determining the path charged particles will take place as they move through electric and magnetic fields. If you also know the particle of mass, that is m, the force is related to acceleration by the equation, that is force is equal to mass into acceleration. The first term in the Lorentz force equation represents the electric force. F acting on a charge Q with an electric field is given by F is equal to small q into capital E. The electric force is the direction of the field. Then magnetostatics, actually it is a study of magnetic field in system where the currents are steady. It is a magnetic analog of electrostatics where the charges are in stationary. Then magnetic field. It is a vector field that describes the magnetic influence of electric current and magnetized material. Actually, in the year 1820, Hans Oersted discovered how the magnetism and electricity are connected. A unit measure of magnetic field strength and the Oersted is named after him. So these are the different types of magnet. Bar magnet is also there, cylindrical magnet, horseshoe magnet, button magnet, ring magnet and U-shaped magnet. So most of the magnets are having two poles are there, that is north and south poles. So magnetic force and fields in the type of magnets. So magnetic fields that must be is equal to surround a magnet and can exert some magnetic force. So it is a field region around the magnet, imaginary lines around the magnetic lines of force. So that can be discovered by a Michael Faraday. The direction of the lines is from north pole to south poles. The line of force are also called as magnetic lines of the flux or magnetic flux lines. Magnetic flux lines exist in the form of a closed loop. That is, it can travel from north pole to south pole. So magnetic flux and magnetic field intensity. So already you know that magnetic flux means that is the total number of lines of force. It can be measured by Weber. So normally 1 Weber is equal to 10 to the power of 8 lines of force. So here the force level that should be somewhat high as comparing to this total number of, that is the flux value. So magnetic field intensity is a force experienced by the unit north pole of 1 Weber strength. So it can be measured in newtons per Weber. So therefore the vector quantity magnetic field intensity B is equal to mu 0 mu r into height. So normally already you know that right hand thumb rule. It is used to determine the direction of the magnetic field around the current carrying conductor. So it holds the currents carrying conductor in the right hand pointing in the direction of current and parallel to the conductor. Then the fingers point in the direction of the magnetic lines of flux around